This one's not too bad. Right, so what we're going to do is we're going to look at the angle defined by the semicircle property. So if we have a circle over here, and AC happens to be a diameter that passes through the center of the circle O because it's a diameter, what we discover is that this guy over here is 90 degrees. It doesn't matter where you drag point B around the circumference of the circle, it always ends up being 90 degrees in there, which is really cool. So what we're going to look at is using our, I guess, fundamental rules around congruent triangles and angle properties. We're going to show for ourselves that this is always 90 degrees, and after that we define it as a rule that we can just invoke to be able to know angles within a circle. Seem cool?
Yeah.
Okay, so have a look at what we have over here. We have A, we have B, and we have C. What shape is this?
Triangle.
Excellent. I was going to say don't think too hard about it, but 3 sides, 3 angles, it's a triangle. And we're trying to show that this is 90 degrees, so I'm going to just remove it for now. Now the next thing, what I'm going to do is I'm going to split this triangle such that there's O to B. And as much as I want to do it in red, I'm going to change it to a dotted black line. And then, how many triangles did we have?
Did we have? We had 1.
We had 1, and now how many do we have?
2.
2 smaller ones and the 1 big one, so we got 3 in total. Now, what sort of triangles are these smaller ones and why?
They are... Is it isosceles triangle?
They are sort of. Because this is, yeah, you're right, sorry. These are isosceles because these 3 sides are what?
The radius.
The radius or the radii, because it's plural. So we can make the statement OA is the same as OB is the same as OC. And the reasoning for this is radii, double I. Or you can say same radius of a same circle, just anything to show that you know they're the same. The wording of the reasoning isn't essential. Okay, now have a think, what are the properties of isosceles triangles? Think of the angles.
They share 2 of the same angles.
Bingo, they share 2 of the same angles. So if this side and this side are equal, then this angle here and this angle are equal, and we'll call it alpha. And similarly, this angle here and this angle here, doubted myself for a second, they're also equal. So my next statement is going to be triangle OAB and triangle OCB are isosceles. Don't have to worry too much about the reasoning there. Welcome, Rob. I'm going to just wind the bag. And therefore, angle OAB is equal to angle OBA. Similarly, OCB is equal to OBC.
It's the day before your birthday, so yeah, we can do that.
Week 4.
It's on week 5.
I tend to just do the quotation marks if it's the same reasoning going down, save writing. Okay, cool. All right, now I want you to think about the unknown angles within this triangle. What would angle AOB be?
180 minus 2 alpha.
180 minus 2 alpha. That would be a good one. Now I want you to use the external angle of the triangle reasoning. The external angle is always dependent on this triangle here to tell us what this angle here is.
The
Wait, is that 3 units? But you guys have a different question.
2 veta. If you sum these two angles, it gives you the external angle here. Do you remember that? Would you remember it now? Probably. And then, similarly, what's this one?
2 alpha.
2 alpha. Excellent. So what we can say is that angle AOB is equal to 2 beta. And I really should define these guys up here. We'll call these alpha and this one beta. We're allowed to do the equal signs across the page in geometry because it just makes it easier to read. So this is 2 beta, and this guy here, COB,
That's your imaginary axis. That's your real axis.
and the reasoning for this is that these are external
How do you make it positive?
angle
So it's
of
somewhere around-
triangle.
As long as you're on that line there. And then how can you deal with that line?
All right. Second last one. What is the relationship between 2 beta and 2 alpha?
What is
180.
2 and alpha?
Once more with confidence.
180.
What is the ring alpha?
2 beta plus 2 alpha gives us 180. What reasoning do we have to believe this?
But since
Starts with
zero
S.
doesn't
Supplementary.
even work,
Yeah.
you can't just make n 0, that's not n 0. What do you go?
Supplementary angles. Therefore, what's alpha plus beta?
Really close. If you go all the way around from there, all the way around
90.
there. Yeah, it's big axis.
What is angle ABC?
I'll land.
90 degrees.
How cool is that?
I think that's how you do that. At least.
This is why geometry is such a fun topic. So using this property, using this reasoning, we're able to show that it doesn't matter where B is, so long as B touches or B is joined to the extremities of the diameter of the circle, that angle there is always going to be 90 degrees. You wouldn't think so, but it is.
Given that X was funny.
But now that you've seen the proof, you kind of know that it is. Seem all right? So the other way we can go as well, we could, if we knew that this was 90 degrees, then what does that tell us about line AC? How does it relate to the circle? If that's 90, what must AC be?
The diameter.
The diameter. So there's two things to pull from here. If AC is a diameter and B is connected to A and C, then the angle ABC must be 90 degrees. If ABC is 90 degrees, then AB must be the diameter. All cool?